Check one. Check one. Right. Good evening, everybody. Today is the sixth day of our MCQ program, which means we'll have to do 2022 O level question number 11 to 20. Today, question number 11 to 20 from 2022 O level paper. Before we start, I still didn't open the group's name. Right, groups are open. Just confirm me whether all the video, audio, whether all the duos are perfect from your side. Zoom okay. YouTube people. Perfect. Great. YouTube okay, no? Black t-shirt again, yeah. I got about 3 of these t-shirts. I repeatedly wear them. All perfect. Working well. Hurry, hurry, right. Without any further delays, we'll start. I guess most of you are starting your school exams by today, isn't it? Today, maybe tomorrow. Most of you are starting your school exams by tomorrow. Yeah, February 11th, there is another set. Tomorrow, there is another set. Hurry, hurry, right. Hurry. Right. 2022 paper. If you go through the paper, Lamai, the second set of MCQ. Now we all know the terms that I use, right? Second set of MCQ means 11 to 20. Second set of MCQ, one calculation type question is there. That is 17th question. Some of you have gone wrong there. Other than that, most of the other questions are direct question, or somewhere you have to use a logic and do the question. Such kinds of questions are only there. Before we start, about today, how was your work plan? Are you satisfied with your work plan for today, whatever you did today? Satisfied with your work plan, whatever you did for today? Do you have the feeling that, yes, I did my best for today? Now it's almost the end of the day. Almost. The day is not over. Do you have a feeling that today you did your best? Those who are feeling still no, you still have time to make today the best day. Still little bit of time is remaining. Today the best day. Or there's a part that I can't concentrate. I'll talk about that. Concentration part, I'll talk about it. Hurry, Ned. For now, we'll start the session. What we have to do today, take your review book. If there are any new students, those who have not come before, you have to get a separate book or anything. A separate book, yeah, no need to buy a new book. A book to write the review. Take that book and get ready. Tell me when you are ready. Get your review book and get ready. Right. Plus. One more point. Yesterday's discussion, after the discussion, I usually put a review to the group. I actually get from the students. They only write and send me. That one I forward to the group. Yesterday I didn't get any review. In case if you have written a nice review, just send me. Today I can forward it to the group. Or if I have directly put it to the group. Directly put it to the group. So I can pin it and keep. If you have the review for yesterday's session, that is question number 1 to 10 from 2022 O-level paper. Hurry, we'll start. Without any further delay, we'll start. I will first discuss the 17th question and finish it off. That's the place where most of you have gone wrong. Most of you means, yes, there is a partial errors there. Partially, some people have gone wrong. So 17th question first I will discuss and finish off. After that, we'll go in the normal order. 17th question. Eyes on the screen, ears on the speaker. Listen very, very carefully. 17. Of the following compounds, what is the compound in which the percentage of oxygen by mass is 50%? Again, read the question. Of the following compounds, what is the compound in which percentage of oxygen by mass is 50%? What do you mean by percentage of oxygen by mass is 50%? You take the compound, there is oxygen, plus some other atoms are also there. If you take the overall mass as 100 grams, out of that 100 grams, 50% of the mass comes from oxygen. 50% of the mass should come from oxygen. So they are asking in which of the following compounds that are given, 50% of the overall mass is oxygen. That means let's take another example. Let's take another compound. The overall mass is, let's take 200 grams. Just imagine. Then oxygen should have how much of mass there? According to the question. Oxygen should have how much of mass there? Oxygen should contribute to how much of mass there? If it is 50%, underwrite 100 grams. So that is what the question is asking. That's what the question is asking. Half of the mass should come from the oxygen. Right. Now we'll go through each and every compound. So what we have to do is, we have to find the mass of each and every compound, that is relative molecular mass, and compare it with oxygen's mass. If oxygen's mass is half of the total mass there, that is 50%. If oxygen's mass is half of the total mass there, that is 50%. One by one we'll go through. First one, ammonium hydroxide. Relative atomic masses are already given. Ammonium hydroxide. First one, ammonium hydroxide. Calculate the relative molecular mass of ammonium hydroxide. Relative atomic masses are given. Nitrogen 14 plus 1 hydrogen 1, 4 hydrogens are there, 4. Oxygen 16. These numbers are already given there. And again hydrogen 1. If you add it up, 14 plus 16 is 30. 30 plus 5 is 35. Relative molecular mass is 35. Oxygen's mass is 16. You all tell me, is 16 half of 35? Is 16 half of 35? Yes or no? All. Is 16 half of 35? No, then first answer is wrong. Second one. Second one. Calcium hydroxide. Calcium hydroxide. Y'all don't need to memorize the relative atomic masses. They will give it in the exam. Calcium 40 plus. Oxygen 16, hydrogen 1, but that whole thing multiplied by 2. Oxygen 16, hydrogen 1, that whole thing twice. That whole thing twice. So if I do the math there, 16 plus 1 is 17, 17 into 2 is 34, 34 plus 40 is 74. Relative molecular mass 74. What is the mass of oxygen? 1 oxygen 16. Tell me how many oxygen are there in this compound? How many oxygen are there in this compound? How many oxygens in the compound? And 2 oxygens are there. Why? After the bracket, you have 2. This 2 belongs to hydrogen as well as oxygen. This 2 belongs to hydrogen as well as oxygen. Then there are 2 oxygen. 1 oxygen 16, 2 oxygen 32. 1 oxygen 16, 2 oxygen 32. 74, 32. Tell me, is 32 half of 74? Is 32 half of 74? Is it 50%? No. So second one also wrong. Second wrong. Going to the third one. Going to the third one. CH3OH. CH3OH. Carbon. Carbon 12. 1 hydrogen 1. There are 3 hydrogen here. 3. Oxygen 16. Again 1 hydrogen 1. Altogether 12 plus 3 15. 15 plus 1 16. 16 plus 16 32. Oxygen. Only 1 oxygen is there. 1 oxygen 16. Now compare. Is 16 half of 32? Yes or no? Is 16 half of 32? Yes. Then this is the correct answer. This is 50%. So basically, oxygen is contributing to 50% of the total mass here. Oxygen is contributing to 50 percentage of the total mass, half of the total mass. 16 is coming out of 32 only from oxygen. So answer is answer 3. Answer is answer. Answer 3. Those who got it wrong now understood how to do this. Those who got it wrong now understood how to do this. Yes. Is there any shortcut to do this? Only the other method is you can calculate their masses in the mind. That's the only way of saving time here. You can calculate their masses in the mind. If you are good at maths, now this one, no need to sit and separately write it. You can calculate in the mind. Nitrogen 14. 14 plus 4, 18. 18 plus 16. 18 plus 16 is 28, 34. 34 plus 1, 35. 35. Oxygen is 16. 16 is not half of 35. So like that, in the mind, maybe you can do. Now here, oxygen 16, 16 plus 1, 17. 17 into 2, 34. 34 plus 40, 74. Oxygen 32. Twice of it is 32. 32 is not half of 74. Hema, in the mind, you can do it. Now, if you do in the mind, now you can see how fast you can do. Other than that, then the other method is writing and doing. So how come nitrogen is 14? Nitrogen is 14. That is the relative molecule, relative atomic mass. Me. Hari. Aren't we checking the 14th one? You can check it, but I have already got the answer. If you want, we will check the 14th. We'll check. Magnesium 24. Magnesium 24. Carbon 12. 1 oxygen 16. 16, 3 oxygen are there. 16 into 3, 48. 48 plus 12 is 60. 60 plus 24 is 84. Again, 48 plus 12, 60. 60 plus 24, 84. Oxygen, there are 48. Oxygen is 48. Total mass is 84. Is it half? Not half. Fourth one wrong. Okay. So that's how you find the mass. Now going in the normal order. Question 11. Which is the phenomenon that cannot be explained by total internal reflection? What phenomenon cannot be explained by total internal reflection? Question 11. What you can't explain by total internal reflection. Now, what is total internal reflection, Lamai? Listen very carefully. What is total internal reflection? Onnapute, you have two medium. One denser medium, the other rarer medium. One denser medium, one rarer medium. Usually, when light ray travels from denser medium to rarer medium, light ray will bend away from the normal. When light ray travels from denser medium to rarer medium, it bends away from the normal. It bends away. From denser medium to rarer medium, it usually bends away. You all tell me, what is this angle? What is that angle called as? Incident angle or angle of incidence. What is this angle? What is that angle? Refracted angle or angle of refraction. Angle of incidence, angle of refraction. Angle of incidence, angle of refraction. Now, when I increase the angle of incidence, automatically angle of refraction will also increase. Listen very carefully. If I increase the angle of incidence, that means if I increase this angle, automatically this angle will also increase. Refracted angle will also increase. That means if I take incident ray furthermore away, refracted ray will also move furthermore away. If I take incident ray furthermore away, refracted ray will also move furthermore away. That's what you mean by I increases, R increase. When I increases, R will also automatically increase. So now, I slowly increase the I value. I increase the I value. In basic terms, I take this ray some more away. I take this ray some more away. When I take it some more away, this ray will also come some more away. It comes down. When this ray goes away, this ray goes down. This ray goes away. This ray goes down. So now, refracted ray goes down, goes down, goes down. At a certain point, refracted ray will go through the separating medium. At a certain point, refracted ray will go through the separating medium. If I draw and show, there you go, normal line. Incident ray, I am taking the incident ray slowly away. When I take it slowly away, refracted ray will also go furthermore away. At a certain point, can you see refracted ray is going on the separating medium? Refracted ray is going on the separating medium. At this incident, the angle of incidence is given a special name. At this incident, now this is a special scenario. Refracted ray is going through the separating medium. Special scenario. At this incident angle is given a special name. You call it critical angle. At this specific incident angle is given a special name, critical angle. And of course, refracted angle is 90. See? Refracted angle is 90. Refracted angle increase. Now it becomes 90. Incident angle becomes critical angle. After this, if I furthermore increase the incident angle, on the chart low, after this, if I furthermore increase the incident angle, guaranteed refracted angle will also try to increase. That means if I make I greater than C, listen to the terms I am using. If I make I greater than C, this is the C value, greater than C, guaranteed R is going to be greater than 90. If I make I greater than C, guaranteed R value will be greater than 90. You all tell me. When R value is greater than 90, this ray will be in the separating medium or it will come into the layer. Tell me, will it be here? Will it be here or here? 1, the 2, the third, 3. When R is greater than 90, is it going to be at 1 position, 2nd position or 3rd position? Practically think it is. And it comes to 3rd position. I'll draw that. Now my I value is greater than C. Guaranteed R will be greater than 90. So what it comes inside. This is 90 and greater than 90 is inside. It comes inside. Now basically R becomes this. This incidence is given a special name. Total internal reflection. This is denser, rarer medium. Denser, rarer medium. Again, see, usually when light travels from denser to rarer, it bends away from the norm. It bends away from the norm. If I increase the angle of incidence, angle of refraction will also increase. If I increase the I value, R value will also increase. If I increase I, R will increase. R will increase. R will increase. At a certain point, it goes on the separating medium. It goes on the separating medium. At that incident, the angle of incidence is given a special name. Angle of incidence is given a special name, critical angle. I is given a special name, critical angle. And at that point, R is going to be guaranteed 90 degrees. R will be 90. After that, if I furthermore increase I, R will furthermore increase. That means when I is greater than C, R will become greater than 90. When I is greater than C, when I is greater than C, R becomes greater than 90. This R, that becomes greater than 90. So automatically, ray will shift into the same medium. This is called total internal reflection. What are the places you can see total internal reflection? Where you can see total internal reflection? Number one, optical fiber. Number two, now optical fiber is used one in communication. Or fiber optics is there. SLT has the fiber optic cables. This one. Right? SLT has it. They first it to Sri Lanka. After that, now so many other networks also have it. This cable with telephone wire, it comes with the Wi-Fi. So that is optical fiber. Number one, it's used in communication purpose. Number two, in medical purpose, it's used for something. What is that? To make endoscope. To make endoscope, optical fibers are used. Other than that, you can see total internal reflection happening in a prism. Basically a rectangular prism. In a rectangular prism, in which one of the angle is 90 degrees. Total internal reflection happens. Light comes, light knocks, light goes. Optical fiber. Light comes, knocks, again knocks, again knocks, again knocks. Now all these places, total internal reflection happens. Finally comes out. Now understood fully total internal reflection. I think you can't have any doubts. Fully clear with total internal reflection. Okay. So what's the condition for total internal reflection? Your incident angle should be greater than what angle? Incident angle should be greater than what angle? Critical angle. Incident angle should be greater than critical. And light rays should travel from denser medium to rarer medium. Only denser to rarer it can happen. Opposite way it can't happen. Denser to rarer only total internal reflection happens. Those are the conditions. Alright. Now we'll do the question. Now all those things are needed for the question, but as we came across this question, I revised everything. Which is the phenomenon that cannot be explained by total internal reflection. Traveling of light through optical fiber, yes. Making diamond shiny by cutting and polishing. I mean, how does diamond shine? Diamond is there. How does diamond shine? Listen, after you cut and polish it in a certain pattern, now let's take a light ray is coming here. Light ray enters. Whatever the light ray that enters doesn't go out, then what will happen to that light ray? Light ray will undergo total internal reflection. This light ray knocks on this surface, reflects. It knocks on this surface, reflects. Knocks, reflects. Knocks, reflects. Knocks, reflects. Knocks, reflects. Knocks, reflects. Knocks, reflects. Keeps on reflecting. As it is reflecting for many times inside the diamond, diamond shines. When a light ray enters, it keeps on knocking everywhere. So from each and every point there, it shines. That is why in movies and cartoons, when they find a diamond, first focus is given to the person who finds the diamond. Why? They show the focus. In the focus, they show in the face of that person, shininess is there. There are points there, there are shininess. That's not because diamond is producing light. That's because when light enters the diamond, it knocks and diamond shines. A glass can't do this. To cut glass in this kind of a pattern, it don't do this. It don't give this. Making diamond shiny by cutting and polishing, yes. Formation of rainbow by dispersion of white light into colors. This is because of dispersion. This is because of dispersion. When light travels through some substance, now for example, when it travels through a prism, it will divide into its colors. It's dispersion, not refraction. So this can be considered wrong. Turning a ray of light by 90 degrees by a rectangular prism, yes. Answer is answer 3. Remember, rainbow is because of dispersion of white light. Dispersion of white light, and white light turning 7 colors. Right. Question 12. Which of the following is the chain that occurs after the process of fertilization of a flower? After fertilization. After fertilization. After fertilization in a flower, what are the changes that will happen? The fertilized ovule turns into the seed. Fertilized ovule turns into seed. The ovary turns into the fruit, the fleshy part of the fruit. Fertilized ovule becomes the seed, ovary becomes the fruit. Additionally, wall of ovule becomes the seed coat. Seed coat means the covering of the seed, the outer covering of the seed. Wall of ovule becomes the seed coat. Wall of ovary becomes the pericarp. Pericarp means the skin of the fruit. Pericarp is the skin of the fruit. Again, see, after fertilization, ovule becomes the seed, ovary becomes the fruit. Ball of ovule becomes the seed coat, ball of ovary becomes the pericarp. Again, repeat with me. After fertilization, ovule becomes the seed, ball of ovule becomes the seed coat. So everything about ovule becomes the seed. Ovary becomes the fruit, ball of ovary becomes the pericarp. Ovary, fruit, ball of ovary, pericarp. So everything about ovary, it forms the fruit. Most of the time, the sepals, they are petals, all of them will fall down. The stigma the style, all of them will fall down, shed off. But in some fruits, vegetables, some plants, the sepal will be remaining attached to the fruit there. Now, for example, if you see brinjal, have you seen on top of brinjal there's this green color part? That is the sepal remaining. Not in all, not in all. In some plants, the sepal will remain. In most of them, it will fall down. So again, after fertilization, what are the changes happening? Ovule becomes the seed coat, ball of ovule becomes, ovule becomes the seed, ball of ovule becomes the seed coat. Ovary becomes the fruit, ball of ovary becomes the pericarp. Again, repeat with me. Ovule, seed. Ball of ovule, seed coat. Ovary, fruit. Ball of ovary, pericarp. Most of the time, petal, sepal, the style there, everything will fall down. But in some plants, sepal will be remain. What is pericarp? Pericarp is the skin of the fruit. What's the question telling? Which of the following is a change that occurs after the process of fertilization of a flower? Ovary turning into the pericarp. Ovary becomes the fruit. Second, ovules turning into seed. Yes. Ovules become the seed. Sepal turning into seed coat. No, sepal doesn't become seed coat. Integument turning into the pericarp. Integument means it's like the covering of the ovule there. It's the covering of the ovule. We don't talk about the covering of the ovule. That's wrong. So answer is answer 2. Ovule turning into the seed. Question number 13. Which of the following is not a characteristic of smooth muscle tissue? Not a characteristic of smooth muscle tissue. Smooth muscle tissue. Smooth muscle tissue. What you should know about smooth muscle tissue? Remember the shape. Spindle shape. Uninucleated. No striations. No intercalated discs. Controlled involuntarily. What else you can tell? It will become fatigue, but not easily. Become fatigue, not easily. Is it branched? Unbranched. Again, what are the things you should know about smooth muscle tissue? Shape, spindle shape. Uninucleated. Remember, smooth, smooth and cardiac uninucleated. Skeletal, multinucleated. First and the last are uni, middle one, multinucleated. So, spindle shape, uninucleated, no striations, no intercalated, um, controlled involuntarily. You can't control it. Controlled involuntarily. Becomes fatigue, but not easily. So do not become fatigue easily. No striations. Again, I repeat, spindle shape, uninucleated, unbranched, no striations, no intercalated, controlled involuntarily, and do not become fatigue easily. Those are the ones. That's direct theory. Which of the following is not a characteristic of smooth muscle tissue? Cells being uninucleated, it's a characteristic. Cells are spindle shaped, it's a characteristic. Having cross striation, where it is smooth lamai, it can't have striations. Acting involuntarily, it's correct. Answer is answer to having cross striation. Question 14. Consider the following statement given about mechanical waves. Statements about mechanical waves. Statement A. Frequency of the wave changes on entering from one medium to another medium. Tell me. Does the frequency of a wave change during its motion? Now, this is the third time we are discussing this. Last paper also we discussed about, will the frequency of a change ever change? Frequency of a wave ever change when it is moving? No. Previous paper also we discussed. Frequency never changes from one medium to another. It never changes. Frequency will never change. Frequency can only change if the source changes. Because frequency is something that depends from the source. It's something coming from the source. If the source changes, whatever that is producing the sound changes, then the frequency will change. On the way, the frequency of a wave will never change. So here they are telling frequency of a wave changes. Wrong. Second, speed of the wave does not depend on its frequency. What do you think? Speed doesn't depend on the frequency. Speed of wave doesn't depend on frequency. Speed doesn't depend on frequency. Yes or no? I appreciate your answers, right? What's the logic you all used? How did you all tell yes? How did you all tell no? What's the question number? Question 14. Sir, guessing bad. How did you all tell yes? How did you all tell no? What's the logic you all used? They're talking about frequency and speed of wave. Frequency and speed of wave dependency. What's the logic you all use? Just in general knowledge. Magic, sir. And some people are saying V equal F lambda equation. Using this, we can talk about this dependency. V equal F lambda equation. V is the speed of wave, F is the frequency, lambda is the wavelength. Now you will tell, answer, when frequency increase and wave, the speed of the wave will also increase. Neither that's how the equation is. In an equation, when something in the right hand side increases, left hand side also will increase. On when frequency increase, speed will also increase. When frequency decrease, on speed will also decrease. Speed of wave is depending on the frequency neither. That's what you will tell. If F increases, V will increase. If F decreases, V will decrease. That means V is depending on F. No. Yes, this logic is correct. But additional one more logic is there. What's the other logic? Listen, whenever when frequency of a wave increases, listen very carefully. Whenever when frequency of a wave increases, the wavelength will decrease. Indirectly proportional. When frequency increases from the source, you increase the frequency. From the source, you increase the frequency, automatically the wavelength will decrease. If you decrease the frequency, wavelength will increase, indirectly proportional. If F increases, lambda decrease. If F decreases, lambda increase, indirectly proportional. When one of these increases, the other one will decrease. When one of these decreases, the other one will increase. Now see, let's take, I try to increase frequency. When I try to increase frequency, the final answer, speed will also try to increase. That's how the equation behaves. When one factor increases, the other factor will also increase. When F increases, we will try to increase. Now we already know when frequency increases, automatically the wavelength will decrease. Listen, when frequency increases, automatically the wavelength will decrease. Now frequency is increasing, automatically the wavelength will decrease. When wavelength decreases, final answer will try to decrease. Again, see, when frequency increase, final answer try to increase. Meanwhile, the wavelength decrease. When wavelength decreases, final answer will try to decrease. This increase, this try to increase. This decrease, this try to decrease. One factor is trying to increase the speed. Another factor is trying to decrease the speed. Then you all tell me, will the speed change? One is trying to increase, one is trying to decrease. Will it change? Will it change? No. It change. Practically think, one factor is trying to increase the speed, the other factor is trying to decrease the speed. It won't change. This is the initial value. One factor is trying to increase the speed, the other factor is trying to decrease the speed. No change. V remains a constant. That means you all tell me, does V depend on frequency? Does it depend on frequency? Can you change V by changing the frequency? Can you ever change V by changing frequency there? No, you can't. Why? When you change the frequency, automatically the wavelength will do the opposite of it. When it does the opposite, whatever the changes that is happening will be reduced. So V will become a constant. You try to change frequency, wavelength will also change. Those two changes will tally, and finally the speed will remain the same. So remember, speed doesn't depend on frequency. Speed doesn't depend on frequency. Okay. Again, I repeat. P equal F lambda. When F increases, lambda will decrease. When F decreases, lambda will increase. Opposite connection. Now, if I try to increase F, V will also try to increase. Meanwhile, lambda will try to decrease. When lambda tries to decrease, V will try to decrease. One is trying to increase, one is trying to decrease. V won't change, V remains a constant. That means V doesn't depend on frequency. Frequency is increasing, but V is not changing. Understood? Means V is the speed of wave. Yeah. Write a good review for this question and keep. So what's the logic you need to understand from this? Does speed of wave depend on frequency? Does speed of wave depend on frequency? Now tell me yes or no. Does speed of wave depend on frequency? No. Why? When frequency changes, automatically it gets readjusted. V won't change. So speed of wave doesn't depend on frequency. And let's take in another paper, they ask like this. Now think and answer me. Speed of wave depends on wavelength. Speed of wave depends on wavelength. Is that statement correct? Speed of wave depends on wavelength. Now this is another paper. They are asking speed of wave depends on wavelength. Is that correct? That's also a no. Same like frequency. No? When wavelength decreases, automatically frequency increases. Then change won't happen. When lambda decrease, F will increase. One decrease, one increase. The final change won't happen. Or remember, speed of a wave. Speed of a wave. Speed of a wave only depends on medium it is traveling. Now, for example, speed of sound in air 330 meters per second. Speed of sound in water 1400 meters per second. Speed of sound in steel 5,000 meters per second. So speed of sound depends on the medium, number one. Number two, speed of a certain wave depends on the temperature. Now this is for mechanical wave, not for electromagnetic wave. Speed of mechanical wave, I'll specifically tell that speed of mechanical wave depends on temperature. Now, for example, speed of sound in air at 0 degrees Celsius is 330 meters per second. Speed of sound in air at 0 degrees Celsius temperature, 330 meters per second. Speed of sound in air at 30 degrees Celsius is 350 meters per second. 0 degrees Celsius, 330 meters per second. 30 degrees Celsius, 350 meters per second. That means speed of sound, speed of wave depends on the temperature. This is for mechanical wave. Now, electromagnetic wave speed, you can't change it by changing the temperature. It's electromagnetic. Final point. This is also for mechanical wave. Speed of wave depends on the humidity, the moisture. Remember, last two are for mechanical wave. That also I'll write and keep. These two are for mechanical wave. So what are the logic you need to know? Speed of wave depends on number one, the medium it is traveling, temperature and humidity. Temperature and humidity for mechanical waves. And speed of wave doesn't depend on the frequency. Speed of wave doesn't depend on the wavelength. Again, I repeat, speed of wave depends on medium, temperature, humidity for mechanical wave. Speed doesn't depend on frequency, doesn't depend on wave. Okay. All right. Medium for both wave, yes. Medium for both wave. Now, if you take electromagnetic wave, in vacuum, speed of electromagnetic wave is 3 into 10 to the power 8 meters per second. In glass, it is less. If my memory serves me is correct, it should be 2.5 into 10 to the power 8 meters per second in glass. So medium changes, speed will change to electromagnetic wave as well as what you call mechanical waves. Again, one more time, listen, put it to the mind. Speed of wave doesn't depend on frequency, doesn't depend on wavelength. Speed of wave depends on medium, temperature and humidity for mechanical wave. So medium, temperature and humidity for mechanical wave. Or the speed of wave does not depend on its frequency. Does not depend on its frequencies. Now tell me, correct or wrong? True or false? Speed of wave doesn't depend on frequency. It's true. It doesn't depend on frequency. Last one. Speed of wave depends on the medium through which it is traveling. Correct or wrong? Speed depends on the medium. Depends on the medium. B and C are correct. Answer 4. Answer 4. Write a good review for question 14. So many things are there for you to review. Question 15. Given below are some information regarding a certain element. It comes second in order of abundance of element in earth crust. Shows semiconductor property. When you hear the word semiconductor property, Lamai, only two should come into your mind. Ekko silicon, නැත්නම් germanium. When you hear the word silicon, semiconductor, silicon or germanium, out of that silicon should be the answer. Shows metallic property as well as non-metallic property. Tell me, out of silicon and germanium, which one is a metalloid? That I discussed in the first paper, somewhere on third or fourth question. Which one is a metalloid? Silicon. Silicon, answer 2. So remember silicon. Silicon is used to make electronic devices. Diodes are made, transistors are made from silicon. And silicon is a metalloid. So answer is answer 2. And one thing to learn from this as well, silicon is second abundant element on the earth. Why we call it the second abundant element? What contributes for being the second most abundant one? Why silicon becomes the second most abundant? Silicon is present in soil. Soil contains silicon, sand contains silicon. So basically electronic devices, electronic equipments are made from silicon from the soil. Or in simple words, they are taking soil, making into a device, selling you. Right? Diode transistors all are made from silicon. Those is taken from the soil. Okay. Question number 60. A group of students counted the number of animals in a unit area of an ecosystem. Those numbers are given below. Butterfly, spider, snail, earthworm, leech, centipede, gecko. What is the number of animals belong to phylum Annelida? Annelida. When you hear the word Annelida, what should come into your mind? Worms. Now put it to the mind. When you hear the word Annelida, what should come into your mind? Worms. Tell me, what are the worms here? Butterfly, nah. Spider, no. Snail, no. Snail belongs to which phylum, Lamai? Snail belongs to which phylum? Mollusca. Snail belongs to mollusca. Earthworm, yes, it's a worm. Leech, yes, it's a worm. What about centipede? Centipede belongs to which phylum? I will tell it's also a worm. It also belongs to Annelida. Varadi, eh? Remember, centipede belongs to arthropoda category. It belongs to arthropoda category. It doesn't belong to the worms category. It doesn't belong to Annelida. Gecko belongs to gecko, lizards. Those people belongs to reptilia. So, however, the question is asking about Annelida, worms, earthworm, and leech. They are asking what? What is the number of animals belong to phylum Annelida and earthworm? 2 plus 1, 3. 3 is answer 2. 3 is answer 2. 17 done already. 18. What is the advantage of using the handle fixed to a door in occasion of opening and closing the door? Why you have a handle on the door? Why you have a handle on a door? Question 18. No? Why you have a handle on the door? You can explain it using the concept of moment. Remember, moment. Moment is equal to force into perpendicular distance between line of action of force and axis of rotation. Moment equal force into perpendicular distance between line of action of force and axis of rotation. In simple terms, moment is equal to force into distance. Force into distance. Means, let's take you have a rod. It is fitted using a screw nail there. Around this nail, you can rotate it. You call it the axis of rotation. This is the axis of rotation. Now, if you apply a force, this rod will rotate. If you apply a force at a distance d, it will rotate. That is moment. You multiply the force by distance, you get the momentum. Multiply the force by distance, you get the momentum. Now, if you increase the distance there, if you increase the distance there, you increase the distance. When you increase the distance, moment will also increase. Turning effect will also increase. You increase the distance, turning effect will increase. That means if you fix the longer rod, you can rotate it using a smaller force. Again, I repeat, if you fix a longer rod, you can easily rotate it by applying a smaller force. Why? When the distance increases, turning effect will increase, moment will increase. So you increase the distance, turning effect will increase, moment will increase. So just by using a small force, you can rotate. Simple question. Let's take you have the dough. Let's take you have the dough. This is your dough. It is fitted here. It's going to rotate around this axis. You try to push from here and try to rotate it. You try to push from here and try to rotate it. First position, second position. It's fitted here. Here you are trying to push and rotate it. Here you are trying to push and rotate it. Where you will feel easier to rotate the door there. Practical question. If you can't think, go to the door and do and see. You're trying to push from the very corner there. You're trying to push from this corner. Where it is easy. Second position. Second position is more easy. Why second position is easier? Can you see? Second position's distance is great. First position distance is less. When distance increases, moment will also increase. So just by using a small force, you can rotate. When distance increases, moment will also increase by using a small force. You can rotate. So now tell me, why the door handles are fitted somewhere here? Are there? Now, have you seen any door handles here? Method. Have you seen any door handles at the first position? No. Why door handles are fitted at the second position? What's the reason? What's the reason? You can rotate by applying a small force. So that is something we apply. So just by applying a small force, you can rotate it. Even now, some doors, even by using one finger, you can rotate it. By applying a small force, you can rotate it. That's the reason. If they fix it here, you can't rotate it that way. So to apply a small force, only door handles are fitted there. What is the advantage of using handle fixed to the door in the occasion of opening and closing it? What's the reason? Adequate of applying low moment of force. If they are talking about moment of force, at least they should tell high moment. Turning effect is high. So this is wrong. Low moment is guaranteed wrong. Being able to execute a greater rotation, we'll go through the other answers as well. Adequate of applying a smaller force. This is the answer. This is directly telling us the reason. Reduction of amount of work done. More than all these answers, this answer directly explains us. More than all the other answers, directly the third one, applying smaller force. Why you fix the door handle, you can apply a small force. That's the main reason. That's the main reason. Okay. 19th one. In the male reproductive system, sperms are produced in testes. Sperm production happens in the testes. So if we mark fourth answer, is it wrong? It's wrong. Now tell me a logic. Why can't you take? No, can you take fourth? Tell me a logic to apply the fourth. The third one, you have logic. Because here they are talking about rotation. Rotation is turning effect. Turning effect is moment. Moment is equal to force into distance. So when distance increases, force, small force is enough. So there you have a logic. Do you have a logic to explain this one? When they're talking about turning effect. Remember, when you are answering statement type question, you should have a logic. Now even that frequency questions, we had logic. For each one, we had logic. Guessing is not a logic. Okay. Last question. What is the statement that is true with respect to all molecules given below? Carbon dioxide, ammonia, water. Electron octet of central atom of the molecule is complete. Of course, yes, Lamai. For any molecule, the central atom, except hydrogen, the central atom should surely have 8 electrons around it. Around the central atom, there should be 8 electrons. You call it the octet rule. Octet should be completed in the central atom. Now, for example, if you take carbon dioxide, carbon double bonded oxygen, one bond will contain 2 electrons. Here one bond, here another bond, 2 bond, 3, 4 bonds are there. 4 bonds. Totally how many electrons are there around carbon? One bond is 2 electrons. 4 bonds are there. How many electrons around carbon? 1 bond, 2, 2, 4, 6, 8. 8 electrons are there around carbon. What else was there? Ammonia was there. NH3. Ammonia. Nitrogen. Single bonded hydrogen, single bonded hydrogen, single bond hydrogen. 2 electrons remaining. Altogether, how many electrons are there around nitrogen? Count. One bond is 2 electrons. So altogether, how many electrons are there around nitrogen? Count and tell me. 2 here, another 2, 4, another 2, 6. Here, another 2, 8 electrons are there. What else was there? What was there? What? H2O. Oxygen central, hydrogen, 4 electrons remaining. Count the number of electrons around oxygen. One bond, 2 electron, 2 electron, 4 electron, another 2, 6, another 2, 8, 8 electrons are there. Remember, in any molecule, central atom should have 8 electrons. That's called the octet rule. Octet means what? 8. 8 electrons should be there around the central atom. 2 exceptions are there. One, aluminium chloride. 2, phosphorus pentachloride. Aluminium chloride, AlCl3. Count the number of electrons around aluminium. How many electrons are there around aluminium in aluminium chloride? And on 6 electrons are there. 2, 4, 6. So here octet is incomplete. Less than 8 electrons are there. Phosphorus pentachloride, PCl5. Count the number of electrons around phosphorus. How many electrons around phosphorus? Uh, 2, 4, 6, 8, 10. More than octet is there. More than 8 electrons are there. So these two are exceptions in octet rule. Aluminium chloride has less than 8 electron. Phosphorus pentachloride has more than 8 electron. But all the other molecules should guaranteed have 8 electron except hydrogen. Hydrogen can't have 8 electron around it. Except hydrogen. Okay. So again, what are things you should understand? All the molecules, they will have 8 electrons around them except hydrogen. This is octet rule. But two exceptions are there. Aluminium chloride, phosphorus pentachloride. Aluminium chloride, phosphorus pentachloride. Here, carbon dioxide, ammonia, water, the electron octet of central atom of molecule is complete. Yes, it is complete. What are the other things too? Only single bonds occur among the atoms of the molecule. Where the inilamai? Carbon dioxide. Carbon dioxide single bond? No, there are double bonds. See? Double bonds are there. That's wrong. Lone pairs of electrons are present on the central atom of the molecule. Lone pairs of electrons. Lone pairs of electrons. Ammonia has lone pairs. Water has lone pairs. Does carbon dioxide have any lone pairs around the central atom? Peripheral atoms have. This oxygen has. This oxygen has. Carbon doesn't have. Central atom, no lone pairs. They are telling lone pairs of electrons are present in the central atom. Wrong. The molecule exists only as gases at room temperature. Where the water at room temperature? Answer. Done. Today's 10 MCQs are also done. 60 MCQs are done with review starting from last Monday. Most of you even didn't realize I have hit half century by yesterday. Those who continuously join all the session didn't even realize we hit 50 MCQs by yesterday. Today 60. That's what I told you. What we do is a stress-free revision plus MCQ program. Any doubts from today's session? So do we need to memorize those structures? I actually teach a method without memorizing logically how to understand the structure. If I teach that again, I need to take a separate day and teach it. In MCQ discussion, we can't do it. In my theory class, I usually teach a shortcut how to draw. As you all asked that question, now after the today's session, on the homework, draw the Lewis structures of oxygen, hydrogen, hydrogen, oxygen, nitrogen, chlorine, water, carbon dioxide, ammonia, one more should come here, methane, HCl, aluminium chloride, phosphorus pentachloride. Today itself, after the class, sit and draw the structures. I want the Lewis structures. In a separate paper. Separate paper, you can take a A4 paper like thing, divide it, all the structures draw. Paste that paper in front, in a door or something. When you look at it every day, again, it will go into your mind. Do it till, do it and keep. If can one person draw it and put it to the, send it to me, I will post it to the group. Then will be more easy. These are the main structures we have in O-level syllabus. From this, you can remake and get any structure. So tomorrow, no class, right? No class. Tomorrow, no class. Eh? Remember, Monday, Tuesday, Thursday, Friday. That's how we go. Any other doubts from today's one? So, is silicon oxide is present as amphoteric? Also about beryllium. No, no. Oxide of silicon. Oxide of silicon is acidic. Slight acidic. Don't think very acidic. Slight acidic. It's not amphoteric. Only one oxide is amphoteric, aluminum oxide. So electromagnetic wave doesn't need a medium, right? So why do the speed of electromagnetic wave depend on the medium? Lamai, electromagnetic wave doesn't need a medium doesn't mean it only travels in space. It travels in water. No? It travels in glass, no? Light. Now will light stop from the space there? No. It can travel in air. It can travel in water. It can travel through glasses. Any transparent medium it can travel. If so, it can change the speed. I don't think electromagnetic wave doesn't need a medium. Means only in a place where there is no medium it will travel. Actually, that's not the way you tell it. You tell electromagnetic radiation do not require medium. Medium is not a requirement. Not a requirement. That's the meaning. Okay. Or with that enough for today. ID. I can't show the ID. All personal details are there. I'll show my driving license. We'll take all the personal details otherwise. No, I can't show the picture. My personal details are there. Just go through the name. That's the name. King's Perosia. I can't show all the details. Harin? Don't know if it's clear. Not clear. Not clear. Ini keren തന്നെ. Then Harin? Mari. That's enough. So that's my real name. Huh. Enough for today then. uh, Still, if you have the feeling that no, the day is not over, you have not done your work, still there is time. Still there is time. You have to finish off the day in the best way you can. Homework from my side is also there. Today itself sit and do. If you want, you can refer your grade 10. These structures are there in grade 10. Chemical bonds, that is in part 1 book. In part 1 book, chemical bonds. In chemical bonds lesson, you have the section. Okay, no? Hurry in. Enough for today. Keep working hard. I'll meet you all again, not tomorrow, the day after tomorrow, with the third set of MCQ.